Hello, 5th and 7th hour physical science class. We're going to be doing something a little different here. I'm going to actually talk to you via recording a little bit about the chapter first, and then the homework that I would normally assign we're going to be doing in class. So let's give it a try. This is the start of chapter 20 called Chemical Bonds. We've talked about combining elements before. We've talked about ionic bonds, covalent bonds, and here we're just going to be talking about combining elements in general. Elements, when they combine, like I say right here, they combine and take on new properties. Like if you look at sodium, and please make sure everybody has their periodic chart out in front of them when going through this. If you look at sodium, we all know that it is a metal. It is to the left side of that stair step. It's actually known as a yellow metal. Chlorine by itself is very poisonous, greenish yellow, and it's a gas. It's to the right of the stair step. But together, actually, we've talked about that, it is a table salt. So when you combine those, let me give you an idea here. We have our metal plus our nonmetal. Go back to our electron dot days. We have how many electrons does chlorine have in its outermost energy level? Well, if you look at the periodic chart, you can tell it is in group 17, so it has 7. So let me fill this very quickly here. And sodium, if you look at the periodic chart, sodium only has 1 electron in its outermost energy level. These guys, when they combine, it is an ionic compound. We have a metal and a nonmetal going here. What this sodium is going to do, it's going to actually lose its electron to chlorine. Now, chlorine is now very stable and has 8 electrons in its outermost energy level. If we look at sodium, one more time, how many energy levels does sodium have? It is in that third row, so we know sodium to have actually 3 energy levels. We just decided and noted on the periodic chart it has 1 electron in its outermost energy level. And if you look at the periodic chart again, the atomic number of sodium is 11. So we know it has actually 11 protons, and as a neutral element, it has 11 electrons. So let me just give you a visual here of what that looks like. So on its outermost energy level, it has 1 electron. That is the electron it's going to lose. When it loses that electron, I'm just going to erase it right here. You see now the under energy level here is filled with 8. It is now very, very stable. Very, very happy. And chlorine now very, very happy. So we're saying that these guys combine to become stable. Sodium's lost its electron, its outermost electron, its outermost energy level, to chlorine combining to make sodium chlorine. Actually, a brand new compound. We eat that. You would not eat sodium by itself. You would not eat chlorine by itself. So what we're going to talk about here briefly is chemical formulas. Just fill this in right here. What these guys, they tell you that, the elements that are present in a compound. Compound, remember, are 2 elements chemically combined. Okay, and it gives you the ratio of different elements that are present. How many hydrogen? For example, here, it's telling me, it's telling me that there are 2 hydrogens. This is telling me 1 oxygen. We never put a 1 here. So these here are called subscripts. That's what I'm telling you right here. Subscripts, just a small number. It's always written below. You're not going to see it like this, okay? You always want to write it small, just like I have it there in the red. Gives the number of, again, atoms present. Again, this is telling you there's 2 hydrogen and 1 oxygen, but we omit the 1 when there's only 1 atom. When you see no number there, you automatically know that is only just 1 atom present, okay? So again, H2O, we have 2 hydrogen, 1 oxygen. This I just have up. This, you've already seen this. These are the elements that you needed to know for the quiz, and you've already been given a copy of that. So I'm just going to buzz right past this. and show you some examples here of some formulas. Do you have to have all these memorized right now? No. But just to give you some common, familiar names and chemical names, some you'll be very familiar with, and probably most of you have no idea what the actual chemical name of some of these are. When we look at SiO2, that is actually silicon dioxide, known, very familiar name, sand. Magnesium hydroxide, milk of magnesia. Some of you probably have heard of that, but do not know it as magnesium hydroxide. Here's sulfuric acid. Probably most of you have heard of that in your grade school days. Actually a battery acid that we use in our cars. Hydrochloric acid, your stomach acid, calcium oxide, lime, dinitrogen oxide, a laughing gas. Some of you may have had, I have not, but that is dinitrogen oxide. Sucrose, very common one, as in cane sugar, okay? These, when you look at this, I want to look at this one first. Get my little pen handy. Here we have 1 silicone, 2 oxygen. On this one, magnesium hydroxide, there's 1 magnesium. Now when you have parentheses like this, you look at the subscript outside the parentheses and it applies to all the elements within that parentheses. So in this one particular, this is telling me I have 2 hydrogen, 2 oxygen, 1 magnesium. That 2 right here only applies to the O and the H, known as hydroxide. That is a polyatomic that we'll get to soon. Here, how many hydrogens? 2. How many sulfurs? 1. How many oxygen? 4. On a hydrochloric acid, we have 1 hydrogen, 1 chlorine. On our calcium oxide, we have 1 calcium, 1 oxygen. On our dinitrogen oxide, we have, this is actually a covalent compound. When we have covalent compounds, we use prefixes. We haven't talked about that yet, but we will very, very soon. So di meaning 2, but if you look at this without the name, just looking at the formula itself, we know that there's 2 nitrogen and 1 oxygen. On our sucrose here, how many carbons? 12. How many hydrogens? 22. How many oxygens? 11. So to give you an idea of formulas and how many atoms are in each of these, require you to have that understanding. This seems to be the trickiest part with most kids, knowing that this 2 right here applies to everything just within that parentheses, okay? Here's just a few more examples. I want to show you ethanol and acetic acid. Acetic acid is another polyatomic that you will have to know very soon. Acetic acid is our common vinegar that we put on certain salad dressings and so forth. Ethanol, known as a grain alcohol, it's one of your purest forms of alcohol. Do not want to drink that. But here in this formula, what we're looking at here, 2 carbon, 5 hydrogen, 1 oxygen, and now another hydrogen. So collectively here, we actually have 6 hydrogen. In this one here, our acetic acid, 1 hydrogen here, 2 carbon, 3 hydrogen, 2 oxygen. So collectively here, we have 4 hydrogen, 2 carbon, 2 oxygen. I hope that makes sense so far. So pretty straightforward so far, I think. Again, we've talked about this. We want all elements to combine to fill 8 electrons in that outermost energy level. We already know that our noble gases, again, please make sure you have your periodic chart out in front of you, have 8 electrons in their outermost energy level. They are stable. They are the least reactive. They're very happy, comfortable. They don't need to associate with anybody. They just like to hang out. They're very, very happy. On the other hand, we've talked about hydrogen too. It is an exception to all these rules. Remember, it will fill with 2, and that's when it's very happy and stable. So all these guys try to take on what we say the dot diagram of a noble gas, because remember, a noble gas, such as, whoops, here we go again. I got to get this pen going each time, it looks like. In neon, oh, I am so sorry. In neon, my pen is not responding. Here we go. Neon is going to look like this. It is a noble gas. Has 8 electrons in its outermost energy level. This right here is the dot diagram for neon, okay? So again, the goal of all these guys, they want to look just like a noble gas. Hydrogen, that exception to the rule, will take on a dot diagram of helium, which is only 2 electrons. Now don't forget, helium is very happy with 2. Hydrogen only having 1, but it likes to be stable. In order for hydrogen to be stable, it needs to have 2. These guys either gain, lose, or share to get stable amounts. Now don't forget your ionic compounds. When you have a metal and a nonmetal, they either gain or lose electrons. Our nonmetals tend to gain, our metals tend to lose electrons. When we have a covalent bond, which I showed you on the board just the other day, 2 nonmetals, they actually tend to share electrons, okay? Talking about those outermost energy levels, okay? That actually is the sum of section 1 in your book, okay? So go over this, listen to it again, make sure you understand your electron dot, make sure you understand your location of everything, which you should from the last chapter, chapter 19, and then we're actually, in the next section, we're going to go on to talking about making bonds, okay? We're going to actually get into the nitty-gritty of ionic and covalent bonds. So I hope this makes sense. Please go over it again, and feel free to do so on your own. Talk to you soon. See you tomorrow. Bye.